Assalamu alaikum. So what we have to do is we have to detect and segment the brain tumors and the MRI images in our dataset. So first of all, we have to install Ultralytics, which includes many other uh, libraries, including the YOLO and SAM tool, which are our models for detection and segmentation. After installing the Ultralytics by this command, I imported the libraries. Matplotlib is being used to plot the results from the model. CV2 is being used to process the images. OS is being used to access the folders. Zip file is being used to unzip the file as I'm using the Google Classroom. So I uploaded the zip file of the dataset on the Google Lab, and then through zip file I unzip the dataset. And then from Analytics, I'm importing YOLO and SAM. Torch is being used to in our segmentation model SAM2, where we need to have give the device name. So that's why I use Torch. And then Globe is being used to get all the test images without uh, without basically without leaving any single image. We are just to access all the images. I installed the dataset from this link, and the data contains train folder, valid folder, and test folder, uh, which further includes images and nibbles folder. Additionally, it have data.yml, which includes names and path mappings of the of the images, and then we have two readme files, readme.dataset and readme.globoflow. So basically, first we extracted the zip file, and then after extracting the zip file through this code, we trained a YOLO 11 model, and we're using YOLO 11 n.pt model. After and here we used data.yml as it includes the path and the data details. Here we used 50 epochs to train the model, and after this training, when 50 epochs are completed, it gives the results, validation results, and then some the attributes of the data. And it also shows where my train model training data is being stored. Here it is stored. Runs under and with my detect and then train. Then after training, I reloaded the best model which we get in our one of the epochs, and then use the best trained model to get the results from on the test images. After getting the result, this for visualizing the result we're getting. For now, I've only shown the first five images that we got after the detection. Then after predicting that, we're using the results of that YOLO 11 model into our SAM2 model. So basically, doing the work of YOLO model again, or just reloading the model again here is that we as SAM2 needs the original images and uh, the results from the YOLO model. That's why we are uh, doing the YOLO model work again. And then after these are the test image, the paths, and then after and here I'm just giving an if statement. If we have GPU available, then it will use the GPU. Otherwise, it's gonna go for CPU. It will run on CPU. So basically, this loop is for looping to loop through the test image folders to just to loop through every image that is in a test folder. This shows the results from the YOLO model. Then from these results, we are applying the SAM2 model. These boxes are basically the uh, coordinates of the basic of our affected area, where basically the detection is being like made. It is basically the coordinates of the detection where our affected area is. These are the parameters of the SAM2 model. Source is giving the source images. Boxes is for coordinates. Verbose is to get the basically it is for the extra information that that our model is can give or not. I chose to I chose for false just because to clean to get a clean output. Save is to save the outputs. Device, as I've told, to just to identify whether to use CPU or GPU. And name is to give the name to the output images. And the reason I'm using IDX is that just to differentiate between all the outputs. Otherwise, if I won't use it's gonna overwrite every image, and at the end, I'm gonna get only one image. Exist OK is false, and then uh, if there is no detection in our results which we got from your image, then it will show there is no detection. So that's why it won't segment the basically the images. After to, getting the output segmented images, we are plotting the results from our SAM2 model. And for now, I've only shown the results of first 10 images that we got. Here are the results. Basically, this zero shows the class, whether it's geloma or any other no tumor or all the class that we have. And this shows this is showing its confidence basically.